Hello, boys and girls. So today is a day. Today is Tuesday, and we are doing lesson 37 problem set. Today is going to be, I don't know, it's going to be a little harder than normal. Once we get going, you'll figure out the pattern in which we do it, but it's definitely more confusing because we are using the distributive property, but in this case it is the best way to do it right now. Your parents would probably disagree because they would want to do it a different way, and maybe tomorrow I'll show you that other way, but I'll explain. I mean, this way is probably more efficient, but I don't know, it's a little bit more difficult. So open up that problem set, and if you don't have the problem set, you don't know where the paper is, that's fine, just use a piece of paper. The first one says, draw tape diagrams to show two ways to represent two units of 4 2/3. So we're going to draw two tape diagrams that show the same thing, okay? So if we want 2 4 2/3, we can just simply do 4 2/3 twice. See, that was simple enough. Now we're going to show a different way. We are going to pull out our whole numbers. Here's 4, here's 4, and we pull out our whole numbers and we have our two fractions. And these mean the same thing. 4 2/3 twice. 4 twice, 2/3 twice. Okay, and then underneath it says write a multiplication expression to match each tape diagram. Well, this is twice, right? 2 times 4 2/3. This means, I have to sneeze, excuse me. Allergies have gotten me. This means we're multiplying 2 times 4, and we're also multiplying 2 times 2/3. My dogs hate when I sneeze. Okay, so these are completely equal, they just look differently. So this is basically what we're going to start with, and this is what we're going to do in our work. But do you see, I have 2 4s and I have 2 2/3, and then when I add them, Penny just sneezed, and then when I add them back up, I'll have the answer. Okay, so we did number 1. So we're on 2A. 2A they did for you, so I'm just going to skip it over. You know me. So we'll start on 2B. It says, oh, well, look at that. 2 times 4 2/3. Isn't that what we just talked about? Okay, so the first thing we're going to do is we're going to separate these two. I'm probably going to have to, you know what? Let me see if I can do it this way so it's longer for you. It might be a little difficult because I can't reach it up here, but all right. Oh, that should be a 2. 2 times 4 2/3. This is the same as saying 4 plus 2/3. If we drew it out, we would have 4 wholes and an additional 2/3. So that's what that means, okay? So let's separate those. This means 2 times 4 plus 2/3. Now, even though this looks like I did fancy stuff here, I didn't do anything fancy. I just separated 4 2/3 into the whole number 4 plus our 2/3. Okay? Now this 2 has to be multiplied for this guy and for this guy. Remember in that tape diagram we just did? We had 2 4s and we had 2 2/3. So first we're doing 2 times 4. See how we get 2 times 4 plus 2 times 2/3. Okay, because we had 2 4s and we had 2 2/3. 2 times 4 is 8, plus, well, 2 times 2/3. 2 times 2 is 4/3. So that looks really weird, doesn't it? This improper fraction, we need to make a mixed number now. So you probably already know this, but 3 into 4 once. 1 times 3 is 3. Subtract, we have 1/3. So this is saying 8 plus 1. Can you see it? Yep. 1/3. So to add these, you add the whole numbers. 8 plus 1 is 9, and 1/3. And we did it. It looks complicated. First step we did was we just separated 4 and 2/3, so we add them together. And then we distribute, that's where the distributed property, the 2 to both of those, because we have to add both of those, or we have to multiply. Well, no, in our tape diagram we were adding both of those basically. So 2 times 4, and then we do 2 times 2/3. Here is where you get your improper fraction, and we fix it to a mixed number, then you add it together. So it seems complicated, but if we just do it step by step, it's not too bad. All right, 3 times 2 and 5/8. 3 times 2 and 5/8. Okay. All right, let's separate this guy first. 3 times, I like to do parentheses just so I can see everything better, you know that. 2 plus 5/8, because 2 and 5/8 is made up of 2 and 5/8, and we add them together. So this 3 is going to get distributed to both of those, because if we did a tape diagram, and we have 2 and 5/8 3 times, we have 2, 2, 2, and then we have to have 5/8 3 times. Now that's not very even, but 5/8, 5/8. So this times this, 2, 4, 6. You already know that 3 times 2 is 6. And then we have to do 3 of these. That's why, can you see it? That's why we have to distribute the 3 to both of those. So that's 3 times 2 plus 3 times 5/8. Oh, my 8 is backward, or sideways. 3 times 2 is 6. 3 times 5/8. You do 3 times 5, which is 15/8. Obviously, we can't just add that together, can we? Change this back to a mixed number. Not back to, but to a mixed number. Once, what do we get? 7? 7/8. So we have 6 plus 1 and 7/8. Add your whole number. 6 plus 1 is 7 and 7/8. It worked. Seems like a lot of work, but once you get going, it'll go by quickly too. All right, 2 times 4 and 7/10. First thing I want to do is separate that. So I have 2 times 4 plus 7/10. Okay, so distribute the 2 here and here. 2 times 4 plus 2 times 7/10. Okay, remember in our diagram, in our tape diagram, we had 2, we'd have 2 of these and we'd have 2 of those. 2 times 4 is 8, plus 2 times 7 is 14/10. 8 plus 10 into 14 once. So we have 1 and 4/10. Add those together. I know you can't see it. I'll move it in a second. I get 9 and 4/10. Look at that. We're already on the back, and we only have 5 more problems to go. 3 times 7 and 3/4. Okay, first thing I want to do is separate my whole number, well, my mixed number, basically. 3 times 7 plus, is it 3/4? Yes. fourths. And then I distribute this 3 to both of those. So we have 3 times 7 plus 3 times 3/4. 3 times 7 is 21, plus 3 times 3 is 9, 9/4. 9/4 doesn't work for us, does it? That's 2, 2 times 4 is 8. So I forgot to finish that. 2 1/4. So we have 21 plus 2 1/4. Add my whole numbers and I get 23 1/4. Maybe at the end of this I'll show you the other way. But you gotta do it this way. Tomorrow's work actually does it this way too. So tomorrow will be a nice, I guess, review of it. This is something that you wouldn't get the first day we did it. We would definitely do it a second day. This would be a really good center one to do, like tomorrow, which we can't quite do centers, can we? Okay, so we're gonna separate these guys. We have 6 times 3 plus 1/2. We just want to separate them so we know that we distribute to both of those. We got to distribute here and here. So we do 6 times 3 plus 6 times 1/2. Oh, I like this one. Okay, 6 times 3 is 18 plus 6 times 1 is 6 halves. What's 6 halves equal to? 3. 2 goes into 6 3 times. So our answer is 21. That's a good one. 4 times 9 1/5. Okay, let's separate this. 4 times 9 plus 1/5. Okay, and then we have to distribute that 4 to both of those because we have 4 9s and we have 4 1/5. So 4 times 9 plus 4 times 1/5. Ooh, this will be good. 4 times 9 is 36 plus 4 times 1 is 4/5. Now if you look at that, boys and girls, we don't have to change that to a mixed number because it's a regular old fraction. Geez, we don't see those anymore, do we? So we just simply have 36 4/5. See how we have this as an addition, and then here's our answer. It's the same thing here. You take this mixed number and you can just separate them. Well, here we had them separated and then we put them together because 36 plus 4/5 is 36 4/5. Look at us, we're on a roll. We have 5 6/8 times 4. Well, this looks different, doesn't it? Can we do it the same way? Yep. You can say, oh, the 4 will go to the 6/8 and the 5, but you know what? If you would prefer to turn it around, turn it around. You're still multiplying the same numbers. Let's make it look like how we like it to look. 4 times 5 6/8. Again, could you do it the other way? Yes, instead of drawing your arrows this way, you draw them that way. But you know what? Make it look like what we'd like it to look like, I guess. 4 times 5 plus 6/8. So we're gonna distribute these. So we have 4 times 5 plus 4 times 6/8. Okay, 4 times 5 is 20 plus 4 times 6 is 24/8. Oh, Izzy's at the door. Skip count by 8s. 8, 16, 24. So 24 divided by 8 is 3. So we get to end with a whole number, a mixed fraction. Izzy, or Penny, stop. Okay, so Our last one, it says, it's Penny, I'm sorry. Penny. For one dance costume, Sasha needs 4 2/3 feet of ribbon. How much ribbon does she need for 5 identical costumes? Well, then that means we are doing 5 times 4 2/3. Well, look at that. It looks like the same thing we've been doing, right? So let's do it the same way. 5 times 4 plus 2/3. We just want to separate those. And now we're going to distribute that 5 to the 4 and to the 2/3. So we have 5 times 4 plus 5 times 2/3. 5 times 4 is 20 plus 5 times 2 is 10, 10/3. All right, so we do 3 into 10. 3 times 3 is 9. Subtract 3 1/3. We have 20 plus 3 1/3. Sorry, that's a little close. Add our whole numbers, 23 1/3. Now, your answer statement should be, Sasha needs 23 1/3 feet of ribbon for the costumes. See, that wasn't too bad. All right, now I'll just show you how your parents will want to do it, if they remember. And I don't mean that in a mean way, I just mean if they remember how to multiply something like that. So we have 5 times 4 2/3. So how we were taught is to change this to an improper fraction. So we know 4 times 3 is 12 plus 2 is 14. 14/3. Okay, and then we're supposed to multiply 5 times 14. 20, 5 times 70. So that means we have 70/3, and then change it back to a mixed number. So 3 goes into 70. 3 goes into 7, 2. Bring down our 0. 3 goes into 10 3 times. 1/3. So here we do have the same answer. So why am I teaching you the other way, the distributive way? It will actually be quicker for the most part. Yes, this way absolutely works, but sometimes you're multiplying really big numbers. Like for example, if I look back at G, I have 4 times 9 1/5. Okay, so if we change this, 9 times 5 is 45 plus 1, 46/5 times 4. So now you have to multiply 46 times 4. 24, 16, 18. So then you have 184/5, and then you have to go back and 3, 15, subtract 34, 6, 30, so we have 4/5. So yes, it absolutely does work. There's more risk of multiplying wrong or dividing wrong. So the other way, the numbers that we're dealing with are much simpler, and so they're easier to work with. But it's kind of one of those things where as you get older, you might end up doing it this way, depending upon your teachers and what they want you to do. So I'll show you, of course. I actually do like the other way better. I'm sure a lot of you probably like that. All right, till tomorrow.